Okay, if a belongs to real numbers and a1, a2 up to an all belong to real numbers, then show that x minus a1 squared plus x minus a2 squared up to x minus an squared assumes its least value at this value of x. Okay, so basically this is a quadratic polynomial, right? This is a quadratic polynomial because if you open these brackets, this is sum, right? These are separated by plus signs. So if I open this bracket, this will be x square plus a1 squared plus minus 2 a1x, right? Similarly, if I will open this, this will give me x square plus a2 squared minus 2 a2x. And similarly, I can think of the next set of brackets. How many brackets are these? This is a1, this is a2 up to an. So there are n such brackets, n such brackets. So how many x squares will I have? I'll have n x squares, right? And what about x? I'll have coefficient of x as negative 2a1, then negative 2a2, and so on up to an. So if I want to write this collectively, the coefficient of x will be, I'll take negative outside and let me take 2 also outside. So inside I'll have a1 plus a2 plus a3 plus up to an, right? I am concerned about this much only. Otherwise I can write the rest of expression also, because the constant term will be nothing but a1 square plus a2 square. Let me write it, a1 square plus a2 square plus and an square, right? So this is the quadratic that was given in this format. Now I need to find that it assumes its least value at this value of x. If you have watched the lectures on maximum value and minimum value of the polynomials, you will know that we obtain maximum or minimum value of the polynomial at x equal to minus b upon 2a, where b is the coefficient of x and a is the coefficient of x squared. So now in this particular polynomial, quadratic polynomial, x will be equal to minus b, that is negative of coefficient of x, right? Negative coefficient of x will be 2 a1 plus a2 plus up to an, divided by twice of a, that is twice of coefficient of x square, that is 2n. Okay, now I can cancel this 2. Now I've got this expression a1 plus a2 plus a3 plus an divided by n, which is the required expression. So if I am given a quadratic polynomial like this, it will assume its least value at x equal to a1 plus a2 plus up to an divided by n. And we have studied about this in our lectures on minimum and maximum value of polynomial expressions, right? This expression will obviously have its minimum value or least value at x equal to minus b by 2a, because the coefficient of x square is positive, right? It is 1. So coefficient of x square in the expression, it is n, right? It is n. Coefficient of x square is n, which is positive because I have obtained it by adding 1 plus 1 plus 1 up to n. So 1 is added n times. All right.